Hello everybody, this is Marius Fourie. I'm from GreenPro Consulting and I'm a professional engineer that is registered with the Engineering Council of South Africa, and I've been in the solar industry since 2013, so it's going on 11-12 years now, providing engineering services. The question I want to address today is why, if you have a small-scale embedded generation system, do you need a sign-off by an electrician who issues a CoC, and you also need an engineering sign-off? And I'm going to discuss this using a much simplified version of the electrical circuitry in your house if you have a SSEG. The first element I want to discuss is all the AC circuitry starting at your supply in the street, which we call the point of supply or the POC. And then there's an AC circuitry that runs right to where you connect to your inverter. Now, between that point and this point, you normally have some AC elements, and that is things like geyser, stove, swimming pool pump, things that draw a lot of power. But they are generally not on backup. So the second part I want to address is when you come out of your inverter, you have a bunch of electrical circuits that are generally on backup. So if you have load shedding, those are the things that you will generally keep alive. And that's things like LED lighting, electronics, which is TV, alarm systems, all sorts of things like that, and fridges and freezers. And they form another AC circuit which is connected to your inverter. Then there are three other elements. The first one is the solar panels, and that connects to the inverter. One of the characteristics here is that it is a DC, and I'm not going to go into it today, but DC is a lot more dangerous and prone to catching fire and all sorts of risk than an AC circuit. And this voltage here is, let's call it, easily up to 800 volt. So it's a much higher voltage than the AC circuitry that you have here. And that connects to the inverter. Then you have the inverter itself with its complications. And the inverter then connects to a battery bank. And one of the characteristics of that is also that it is a DC connection, and generally the current flowing here could be much higher. The maximum here, call it in a normal house, is 63 amp, whereas this can quite easily be 160, even going up to 250 amp connected between the inverter and the battery. So now the question is, which elements are actually covered by a CoC sign-off? And simply, it is the AC electrical circuit from the point of connect in the street up to the inverter. So that's the first part of the circuitry that is covered by the CoC. And the second part is everything that is driven by the inverter. As I said, those are your electronics and LED lights and things like that. Which are generally not high consuming electronics, but you want them available when there is a power failure. Then we can look at the rest of the elements. The PV panels, as we said, that is the first element that is covered by the engineering sign-off. Then the connection to the inverter itself, and there's protection equipment in there, in that circuit. Then there is the inverter itself, which has got a huge number of complexities and characteristics. And then there is the DC connection, which is not that high voltage, but extremely high current between your inverter and your batteries. And these three elements are covered by the engineering. So as I said, my name is Marius Fourie from GreenPro Consulting. And I hope that clarifies a bit why do you need a CoC as well as an engineering sign-off, and which elements of your household installation is covered by the two different sign-offs.